Hello everyone, in this video we are going to discuss about ABG analysis and acid-base disorders. So what is ABG? It is arterial blood gas report. So whenever we see this ABG analysis, we will see three things: pH, partial pressure of carbon dioxide and bicarbonate levels. We have to note three things. First thing we have to see is pH. We have to note the normal pH is 7.4. If it is less than 7.35, it is acidosis, and if it is more than 7.35, it is alkalosis. So first coming to acidosis. Whenever we see acidosis, the bicarbonate levels should be low or the carbon dioxide level should be high. So we will see whether the bicarbonate levels are low or carbon dioxide, partial pressure of carbon dioxide is high. If the bicarbonate levels are less than 24 milliequivalents per liter, it is metabolic acidosis. And if the carbon dioxide levels are more than 40 millimeters of mercury, it is respiratory acidosis. And next coming to alkalosis, we have to see whether the bicarbonate levels are more or partial pressure of carbon dioxide is less. If the bicarbonate levels are high, it is metabolic alkalosis, and if the carbon dioxide levels are low, it is respiratory alkalosis. So the compensatory mechanisms will be: for acidosis, the compensation will be alkalosis to neutralize the pH. For metabolic acidosis, it will be respiratory alkalosis. For respiratory acidosis, it will be metabolic alkalosis. For respiratory alkalosis, it will be metabolic acidosis, and metabolic alkalosis, it will be respiratory acidosis. In cases of metabolic disorders, it will be a fast compensation, but in cases of respiratory condition, it will be delayed compensation. So in cases of metabolic acidosis, we can use Winter's formula to see whether the compensation is up to the mark or not. The formula is partial pressure of carbon dioxide is equal to 1.5 into bicarbonate levels plus 8 plus or minus 2. So let us see a clinical case. A 60-year-old woman with a history of hypertension is taking loop diuretics and complains of muscle cramps and weakness. Here the ABG findings. First is pH. The pH according to this is 7.50. So it is more than 7.34. That is, it is more than 7.4. That is metabolic, that is alkalosis. So whether we have to see whether it is metabolic or respiratory. If it is metabolic, the bicarbonate levels should be more than 24. If it is respiratory, the carbon dioxide levels should be less than 40. Here the bicarbonate levels are more than 24, that is 34. So it can be metabolic alkalosis. Here the carbon dioxide levels are less than should be less than 40, but it is more than 48. It is 48. So it is not metabolic respiratory alkalosis. So it should be metabolic alkalosis with respiratory acidosis as a compensation. So then we have to see whether the compensation is good, up to the mark or not. So the formula is: the partial pressure of carbon dioxide expected is 0.7 into bicarbonate levels minus 24 plus 40 plus or minus 2. So 0.7 into 34 minus 24. 34 is the given value, minus 24 plus 40 plus or minus 2. So 7 plus 40 plus or minus 2 is 45 to 49, the range should be. Here the range is 48. So it is good compensation. So we have to know two formulas: for metabolic acidosis, Winter's formula, and metabolic alkalosis, this formula. So in cases of respiratory acidosis, the compensation should be metabolic alkalosis. So the bicarbonate levels should be high. So in respiratory acidosis, there will be decrease in the partial pressure of carbon dioxide. There will be increase in the partial pressure of carbon dioxide. So for every 10 mmHg of increase in carbon dioxide levels, there should be plus 1 increase in the bicarbonate levels in acute conditions and plus 3.5 increase in the bicarbonate levels in chronic conditions. In respiratory alkalosis, the PaCO2 levels will be decreased, and the bicarbonate levels should be reduced to cause metabolic acidosis to compensate the respiratory alkalosis. So for every decrease in 10 mmHg, there will be minus 2 decrease in the bicarbonate levels. For every decrease in 10 millimeters of mercury of partial pressure of carbon dioxide, there should be minus 5 decrease in the bicarbonate levels.